artificial intelligence will completely transform our world. But what is AI? Why will it affect you? And how can you and your business survive and thrive through the AI revolution? Welcome to AI and You. Here is your host, author, speaker, and futurist, Peter Scott.
Hello and welcome to episode 189. Today, we'll conclude the interview with Peter Norvig, who is co-author with Stuart Russell of the standard textbook Artificial Intelligence: A Modern Approach, used in over 1,500 universities worldwide. Peter is a distinguished education fellow at Stanford's Human-Centered AI Institute and a researcher at Google. He was head of NASA Ames Computational Sciences Division and a recipient of NASA's Exceptional Achievement Award in 2001. He's taught at USC, Stanford, and Berkeley, from which he received a PhD in 1986 and the Distinguished Alumni Award in 2006. Recently, he co-authored an article in Noema magazine titled Artificial General Intelligence is Already Here, arguing that today's frontier models are displaying the key property of generality that puts them within the definition of AGI, and we'll be talking about that in this half of the interview. Last week, we talked about the evolution of AI from the symbolic processing paradigm to the connectionist paradigm or neural networks, and Peter's experiences in blending the worlds of academia and business. One note of explanation here, our conversation this week mentions Eliezer Yudkowsky, whom you may be familiar with, especially as he's appeared on a lot of podcasts recently. But if not, the relevant encapsulation would be that he is a researcher who has done some seminal work on the existential threat of artificial superintelligence, and has recently been saying that AI has reached a point where the inevitable future is that it will destroy humanity, and that our only hope is to destroy data centers with airstrikes. It requires a strong constitution to listen to Eliezer's full argument without getting depressed, but we certainly cannot afford to ignore him. Anyway, back to the interview with Peter Norvig. Let's go back to where you were with releasing the textbook, because at that point, having created a standard text, a table-thumping 1,000-plus pager, used for undergrad or as grad or both artificial intelligence, that signifies being fairly deeply embedded in academia, and yet you came out of that field shortly afterwards. What was it enticed you to make the jump?
So I guess a couple of things. One is I always thought of myself more as a builder. I wanted to make things, and rather than just publish lots of articles. And I thought of myself as a teacher. I want to try to explain things. And so the path towards getting tenure was really focusing on things that were not the main things that I wanted to do. So that was part of it. And then the second part was we're moving into this era of big data. And I just felt like I couldn't get the resources I need as a young academic to build up the team I needed to handle things at the scale. And back then, that scale was a lot smaller than the scale that we're dealing with now in terms of the huge number of GPUs and so on, and the large teams and so on. But it was just a lot easier to do that in industry. Industry was saying, yes, this is the kind of thing we want to build. We can give you the resources you need. And so I ended up making that move. But throughout it, I sort of kept my connection to the academic world. Every decade or so, I would go back and teach. In 2011, Sebastian Thrun and I said, we're going to do an online class on AI, and we were able to do that. And I was able to troll all my friends from graduate school saying, you've been a professor for 25 years, and I just passed you in total number of students taught in one semester. So I've kind of always had foot in both camps.
And what sort of doors did having access to the data that Google had open up for you?
Yeah, so I think I went through various different places, ended up at Google at a time when some of my friends were warning me, oh, you're giving up a steady job to go to this risky startup. And I said, I think I'll be okay. And it turned out fine. And it just seemed to be the best place at the time to say it had the access to the most data. It had sufficient computing power. And at a time when there was sort of a dot-com crash, Google was the place that was attracting kind of the best researchers and engineers. So it seemed like a natural place for me to go. It was a place where I really recognized the value of having access to large amounts of data, the computing power to say we can create a copy of the web and process all of it, and the interactions with people saying, we showed them a search result and they clicked on this link and not on that link. That must mean they like it better. So those human judgments were important as well. So I recognized the power of data. And then a few years later, I recognized that data, yes, is a fantastic asset, but it can also be a liability. And that was a new aspect for me. This idea that some data maybe is so important to a user that you'd rather not hold it because the risk of some sort of a data breach is too great, or even if you are a perfect steward and you don't have any data breaches, the risk of people thinking that you might, or that you might be misusing it some way is too great. And that was a change for me to realize that it could be a liability as well as an asset.
Now, that's a very interesting transition there when you're talking about the growth of the importance of ethics in this field. When you wrote the textbook, that's something that's by definition going to be inaccessible to 99% of the world's population because the market is maybe 0.1% of the population. That's not a slight, that's intentional. That's the nature of any textbook. But artificial intelligence now is of immediate interest to a huge proportion of the population. It's not out on the fringe. It's not something that, those eggheads do somewhere. I don't know what that is. An enormous proportion of the population is now actually using it. And the ethical questions have exploded. They were going ballistic in 2016, of course, although it was mostly with Terminator pictures. But now it's gradually getting more and more refined. Do you feel that the size of the audience that you want to address has now increased? Do you feel called to now speak to a broader audience than you have been used to?
Yeah, I think that's exactly right. So starting with the textbook, I already see that expansion sort of over the editions. So we always had a philosophy chapter in the book because we thought that was important. We always covered ethics. But the overall thrust, I think in the first edition, we were kind of saying, AI is part of computer science. Computer science is about algorithms. So this book is going to be mostly algorithms. And then there's some philosophy and other stuff as well. In the middle editions, we said, we're now in this era of big data. So we still got all the algorithms in the book. But honestly, if you want to make your system better, you're probably better off improving your data rather than trying to improve your algorithm in most cases. Then in the most recent edition, I think we shifted to this point of view of, you got to have the algorithms, you got to have the data, but you can download them from GitHub. They're available. And the hard part really is when you apply a machine learning system, you're trying to optimize something. You have a utility function or an objective function that you're trying to find the best solution for. And picking that may be the hardest part of all. Deciding what it is that you want to optimize, deciding what's fair, what's equitable. And in the early editions, we just said, well, your professor or your boss is going to hand that to you and your job is to implement it. Now we're saying maybe that's the hardest part of all, is deciding what is it that we're trying to do. And so ethics really comes into play. And as you say, I felt like maybe I should be addressing a broader audience than just this small circle of nerds. And that's the main reason why I joined Stanford, the Human-Centered AI Institute, was this ability to speak more freely and go back to, you said 2016, maybe around there, or maybe a few years before. I felt the ability to talk to anybody. So I could go somewhere and they would say, the experts from Google are coming. This is going to be so awesome. We're going to learn so much. In the last couple of years, I've really felt this tech backlash of people saying, you're from big tech, you must be biased, so we don't want to listen to you. So it seemed like a good time to tack a .edu at the end of my name, make it easy to, have the same message, but different messenger, and it would go down better. And so at Stanford, we're able to do things like we just did a AI boot camp for congressional aides. And these are people who work for the Congress people. They're not computer scientists. They're generally lawyers or MBAs or something like that, but they have a good grasp of technology in general. They're on the science and communications committees or something like that. And we were able to give them an overview of what they should know about AI. And I think you're exactly right that it touches everybody's lives now. So it's important to communicate that to a broader class of people and not just the people that are in the university taking a class.
Well, that reminds me of Jeff Hinton recently leaving Google very prominently so that he could warn about where he saw AI potentially going without feeling that he was going to violate a contract with his employer. When you think about that kind of conversation and things like the public letters calling for slowdowns, where do you stand with respect to the caution message?
We had a student in a data science class who, as a project, wrote to as many signers of these various letters as they could and got a pretty good response. And my summary of their responses was these signers were saying, look, you're asking me to sign or not sign this letter. So I only get one bit of feedback. And what do I want that bit to mean? And almost all of them said, it doesn't mean that I agree with every word in the letter. And it doesn't mean that I believe that there is an existential threat to humanity. What it means is I think this is an important issue that we should be thinking more about. And I think that's exactly my thoughts as well, that this is really important, that there are lots of harms, some of them coming from people that I respect, but that I don't really understand. It's not high on my priority list to say, you mentioned these pictures of the Terminator, and that used to be the view of what AI was. I don't think that's a threat to us. But I think there are lots of other threats of loss of privacy, of concentration of wealth into the hands of a few. And that's not really a property of AI. That's a property of software in general. Anytime you have goods with zero marginal cost to reproduce, that's going to tend to spread and that's going to tend to concentrate wealth, and that could be bad for society. Then I'm also worried about sort of any powerful technology in the hands of people that want to do bad can help them to do that. And I think we're doing a pretty good job of trying to reach that threat ahead of time. So there have been multiple efforts saying, what can we do against a bad guy who wants to create a pathogen to infect 1 billion people? And fortunately, the answer so far seems to be, yeah, that's kind of hard to do. And some of the key steps to do it, if you're an expert in biology, you know what they are, and they aren't written down anywhere. So right now, you can't find them with a Google search. You can't find them by asking a large language model. But the threat is, well, what if the large language models become good enough so that they're as smart as a PhD in biology, and even if these key steps are not written down anywhere, you can somehow ask it, and it could say, well, I don't know the answer, but what I would try is to put these 4 steps together, and maybe that would work. And so we want to make sure that these systems don't do that kind of cooperation. And that's a little bit hard to do, right? So we've seen these various kinds of jailbreaks where you try to protect against that, but they can always be fooled. And in some sense, that's always been true. That's been true for people as well. They get fooled all the time, but we want to make our systems more resistant to that.
Reminds me of Eliezer Yudkowsky's quote that every 18 months, the IQ required to destroy the world goes down by a point.
So I love that quote. I think he's great, and I appreciate all he's done. I don't quite understand the level of concern that he has. And though I appreciate the quote, I think part of the problem is focusing on intelligence as the only attribute that matters. And Kevin Kelly has a word for this. He calls it intelligentism or maybe thinkism. And he says it's like racism. It's saying, thinking that intelligence is the most important attribute. And I think if you want to play chess better, then yes, knowing more or being able to compute faster, that's going to help you win. If you want to solve the Middle East crisis, then being able to think twice as fast just means you're going to get frustrated twice as fast.
Right.
There's some problems that just aren't solved by being smarter.
As we can observe, the smartest people in the world are not generally the most powerful. They're often sitting at the top of an ivory tower somewhere, wondering why they're not as rich as the guy that dropped out of high school. But it's a very complex problem to navigate. We've spent nearly 200 episodes on that already, so appreciate the dimensions of this. Now, one of those dimensions is this question of artificial general intelligence, and the definitional problems with that alone are enormous, but this is one of the terms that is thrown around that many people think has some kind of meaningful definition. And maybe you could tell us what that would mean, or what that does mean to you, and if we could even encapsulate it on a scale, like 0 means we don't have any, 1 means we've got whatever full artificial general intelligence would mean to you, where you think we stand in that scale.
Yeah, so it's hard, and I think part of the problem is, as you say, is definitional, that we have this one term, but we have dozens of different definitions of what it means. And so people argue when they're not really arguing over the same thing. Mary Morris had a nice article out, at least in Archive, that goes over different definitions. So I think that's useful. Blaise Aguirre and I wrote this article about a month ago in which we said, the title of the article was AGI is already here. And what we meant by that was saying, well, there's lots of different definitions of AGI, and we're not going to argue that our definition is right and your definition is wrong, but we're going to try to think of it from the point of view of someone from the future who comes back and, say 20 years from now and says, what do we think about this? How did this all evolve? And we think what they're going to say is this period, say from 2021 to 2023, that was the time in which we moved from writing programs that did one thing, I talked about the expert systems that were designed to do one task, to writing programs that could do lots of different things, building these models that had an unbounded number of different things they could do. And we thought that that would be the defining aspect of artificial general intelligence. And just as in 1945, the ENIAC computer was unveiled, and it was a terrible computer by today's standards. It was slow and huge and clunky and so on. But it was completely general in that it could be programmed, and it had loops and conditionals and sequences. And, there's sort of a mathematical proof that if you can do that, then you're a general purpose computer. And so the ENIAC from 45 is recognized as a general purpose computer, although it's certainly not the end of computing and had lots and lots of flaws. And so we think we've made that important step towards generality. We certainly haven't made the step of human level or superhuman level. And people argue about, does AGI, what does it mean? Do you have to be human level, be superhuman level? And they argue about, does it have to be across all tasks or just some tasks? If it's all tasks, then I'm not general, right? Because I can't play the flute, say. So lots of things I can't do. And so we'll continually have arguments about how good you have to be. But I think we made that most important change to saying we now build systems that can do an open-ended number of things rather than basically just do one thing.
Actually, you make an interesting point there that we could say that today's large language models are more general than any human because they can converse on a wider variety of topics than any one person could.
Yeah, I think that's right.
What is your reaction to the way that we're interacting with, for instance, GPT-4? I mean, every day there's something new about the way to prompt them. I just saw a paper that's in a preprint of a study that said there was a measurable improvements in result when you tell GPT-4 and others that my job depends upon this. Like if you browbeat it, if you use emotional blackmail. And I thought, this has got to be some sort of parody of computer science. Like, where did this come from? But there is so much of this, like saying please or don't make up the answer actually works. And on one level, this offends me as a computer scientist, but I've also got to acknowledge that it works. and that we now have computers that I program by arguing with them. So how do you feel about what's happened with large language models and where that's going?
Yeah. So I think it all comes from the fact that we train them from giving them lots of human written text and having them learn from that. So in some sense, they learn to, I won't say act like, but maybe mimic is the right word, to mimic what humans do. And humans are susceptible to those kinds of arguments and so on. So it kind of makes sense that that's what they end up doing. Now, from an engineering point of view, I think we should be able to build all those things in, maybe, sort of one at a time as we learn them. So those things you mentioned is also this chain of thought reasoning where you say, show your reasoning step by step, then it does better on a multi-pass thing. You shouldn't have to tell it that for every question. Rather, you should say once, one of the things you can do is chain of thought. And if it's useful, then go ahead and do it. And I'm not going to have to mention it again. So I think soon we'll have systems that you can do that rather than having to fine tune the prompt every time. But I think it is, it really shows that we have an amazing technology here. And the amazing technology is not so much neural nets. It's this 5,000-year-old invention of writing that actually worked so well. And I think that was another thing that would have surprised me decades ago, that I thought language was a reflection of part of what's going on in the world, but I felt it had to be mediated by the listener to fill in all the blanks. And I thought there were lots of blanks. And now I think we're learning that maybe there are fewer blanks than we thought, and that language really does capture a huge amount of what's actually happening in the world. And this is a reflection of that. So that's another surprise.
Do you see the differences between AI and human thinking shifting here? Like, for instance, some things that used to be reliable boundaries, like you could say humans can do one-shot learning, AI needs to learn from 100,000 examples. Those boundaries seem to be getting blurred now with some of the things that you can do with large language models. How would you describe the difference between AI and human intelligence at the moment?
I guess one way to look at it is that we're training these systems to mimic human intelligence to some degree. And so we're seeing much more of that than we ever saw before. But the mimicry is incomplete and in a way that we don't quite understand. Right? So it gets lots of things right, does types of reasoning that we used to think only humans could do, but it gets lots of things wrong, and it's hard for us to predict where it's going to go wrong. So I think we don't quite understand what the differences are yet. And I think it's interesting that we now have sort of two fields. One is to build these systems, and then the second is to reverse engineer them and understand what it is that we build. And, and traditional software, that wasn't really true. It's like, you build it, and while you're building it, you make all these assertions and you know what it is you're building. But now there's two separate enterprises.
Could be a whole new field there. Well, as our time draws to a close here, you've been in the field from, as you said, an AI winter when funding essentially dried up to an era where tens of billions of dollars have been thrown at it in the last few months. What do you think that level of attention and resource investment is going to do to the field? Where do you see it leading?
We had this term AI winter. From the inside, never felt quite like that, right? Maybe it was that slight cooling, had to put on a sweater, but not a down parka. But certainly there is an explosion now. One of the things I think is really interesting is if you track the popularity of the terms AI versus machine learning, right? So it used to be machine learning was a small subfield of AI, and AI was a dominant term throughout the 80s and 90s. Then around 2000 or so, I think there was a general feeling that AI was overstretching or overpromising, and machine learning became the dominant term that everyone would use. And it's only in the last few months that it's flipped again. And now machine learning is just an underlying technology towards this general purpose AI. So as you say, there is huge investment now. I think that's really valid, and I think we'll see good returns from that. And I think it offers possibilities that we've never seen before. So I was talking to a friend who's a climate scientist, biologist, researcher, thought of himself as maybe a little bit of a data scientist, but not really a programmer. Could like pull data out of a spreadsheet and make a chart. And he said, he's bird migrations. And he said, well, I always wanted to have a nice interactive application where I could have a map and see what the data was showing. He said, but I never felt like I was a good enough programmer to do that. And then he asked one of these large language models to help him write the code and was able to do it. And so I think that's a great opportunity. Now, scientists like that, that's not the biggest marketplace, but I think there's a huge opportunity for kind of enterprise level programming for the smaller businesses. So right now, if you're a huge company and you have some task you want to do, some workflow that a lot of your employees use, you can build it in-house. If you're a medium-sized business, you can get Salesforce or somebody to build it for you. If you're a tiny business with 10 employees, you can never afford to do that. You didn't have the skill and you didn't have time to do it. Now, of those 10 employees, they do 5 different things. And, each one of them can say, here's what I do. Build me a program to help automate that. And I think that's something we never had before. So this is different than past winters and summers for AI. It offers opportunities that we never had. So I think the investments are justified. Will there be a crash of some kind? Sure, because reporters have to write something. And after they've written a couple stories of how great everything is, it's time to write a story of how terrible it is. And so there'll be continued waves of that. But I think there really is an opportunity here that we haven't had before.
Well, one last question before the wrap up. Does any large language model chatbot form a useful part of your life at this point?
I would say not a crucial point, and maybe I'm a Luddite in that form, and I should be doing more of it. And I think I use them more to play with them and see what they're doing. So the value to me is more to see, can they do the task rather than actually to do the task. But yeah, sometimes I say, oh, this would be a good thing. Let me see if this chatbot can handle it. And sometimes they do. So I've accomplished something that's useful to me, but the main benefit is now I have another data point on what it can do and what it can't do.
I understand, relate to that. Well, our time is drawn to a close here. Peter, what would you like to tell our listeners about where they can go to follow what you're doing or any other resources that you think is important to become educated about?
Yeah, I guess there's a lot of different resources. So I'm at norvig.com. I'm on GitHub. I'm on LinkedIn. You can find me there. So many possibilities. I don't want to start to just name favorites, but follow me and I'll point to useful others who are doing a good job of covering the field.
Okay. Well, thank you very much, Peter Norvig, for coming on AI and You.
Yeah, great to be here. Thanks.
That's the end of the interview. I thought that was a really well-rounded encapsulation of some of the pivotal history and evolution of AI and its acceptance around the world. In today's news, ripped from the headlines about AI, a team of researchers in Japan claims they have used AI to translate chicken language. That's right, the team from the University of Tokyo says they can tell you what means. They recorded and analyzed samples from 80 chickens. They then fed these samples to an algorithm to relate these vocal patterns to various emotional states in the birds' hold aggressions. By teaming up with 8 animal psychologists and veterinary surgeons, the researchers say they were able to pinpoint a given chicken's mental state with a surprisingly high accuracy. So maybe now they'll be able to tell my local egg supplier down the street why her chickens are broody and haven't supplied any eggs for me for a while. They did acknowledge, however, that the accuracy of their model may change with different breeds and environmental conditions, and that, quote, the dataset used for training and evaluation may not capture the full range of chicken emotional states and variations, end quote. Well, clearly further research is needed. Next week, my guest will be Frank Sauer, Senior Research Fellow at the Bundeswehr University in Munich and member of the International Committee for Robot Arms Control, to talk with us about the dangers of autonomous weapon proliferation. That's next week on AI and You. Until then, remember, no matter how much computers learn how to do, it's how we come together as humans that matters.
That's all for this episode of AI and You. please leave a rating and comment and share with your friends. Get the book Artificial Intelligence and You and see more videos and articles at aiandyou.net. That's aiandyou.net, where you can also send us your questions. Thank you for listening.